Hello students, you're on to Dr. OJ's tutorial class. Don't forget to click on the notification button so that each time I upload a video you'll be duly notified. So thank you. Now we continue with absolute value function. We have discussed constant function, linear functions, quadratic functions, cubic functions. So we move to absolute value function. So in this video I will illustrate with relevant examples. Now before that, let's pick a value x. The absolute value of x is written this way and is defined as what? X if the value of x is positive and minus x if the value of x is negative. Okay, so let's sketch a graph of absolute value, but we start with this example. Sketch the graph of each of the following The first one, y is equals to absolute value of x. The second one, y is equals to absolute value of 2x minus 1. Let's quickly solve this problem. Very simple question. Okay, now let's solve the problem. I think we can do it here. Yes, we can do it here. Now, solution. The first one, y is equals to absolute value of x. As we have defined it before, so we define is x if x is positive and is minus x if x is negative. So how do we sketch this? This is just it. From this illustration. Now, this is the center 0. So the absolute value of x is x if we have positive value x less than greater than equals to 0. So we have this side x greater than equals to 0. So this is what? Y is equals to x. That's the value of absolute value when x is positive. But when it is negative, y is equals to minus x. The second one. That's the second hand. Okay? Now, the domain of this function is all set of real values, that is set of real numbers. This is x values there, they are all, see, you can see that x goes to the right, x goes to the left. So we have so many values of x. So that's why we say the domain of the function is a set of real values, set of real numbers. Now, the range from this illustration, you see that the range means the values of your y. So y moves from 0, you can see 0, and goes up and on and on. So we can define it like this. Simply, we can say the set of y, the range is a set of y such that y is greater than or equals to 0. That solves the problem. Yes, that's the range of the function. Now let's look at the second example. We are done with that. We have sketched what we are asked to sketch. Let's look at the second example. The second example says we should sketch the absolute value of 2x minus 1. That's the second example. Now we first define the absolute value of 2x minus 1. We define as 2x minus 1 will be 2x minus 1 if s is greater than or equals to 0, or let's say, okay, let's write it this way. If 2x minus 1 is greater than or equals to 0. Let's take it step by step. I hope you understand. Fine. It will be minus 2x minus 1 if, 2x minus 1 is less than 0. I hope you understand. Just as we have defined, or we defined absolute value of x. We said x greater than or equals to 0. It is going to be x if s greater than or equals to 0. It is going to be minus x if s less than. So our x in this case is 2x minus 1. So that it will be x, it will be positive value of x if the value given to us is positive. It will be negative value. We are putting minus outside here because it is like minus x. So as not to confuse ourselves, we have to put 2x minus 1 in bracket. So minus 2x minus 1 if the value given to us is less than 0. So let's find out. So we have to solve. Because for us to be able to sketch this graph, we will need to find the values of x, we need to find the value of y. So to sketch, 2x minus 1 greater than or equals to 0, what will be the value of x there? We have 2x greater than or equals to 1, x greater than or equals to 1 over 2. By the time you take 1 here, it becomes plus 1. So divide both sides by 2, you have x greater than or equals to half. For the second one, we have 2x minus 1 less than 0, 2x less than, take your minus 1 here, it becomes 1, x less than 1 over 2. Fine. We have gotten the values of x to be greater than or equals to 1 over 2. So we can now conclude, we can rewrite this one out. Now we write this. The absolute value of 2x minus 1 is now what? Is 2x minus 1 if, what value did you get for x there? X greater than or equals to half. Yes. Why the second one now? It's a step function. It's going to be what? When you expand this, you have what? Minus 2x plus 1. That would be minus 2x. 1 minus x. If x is less than half, because that is what satisfies that. I hope you understand, because by the time you expand this, you have minus 2x plus 1. You can write it as 1 minus 2x. Minus 2x plus 1. You can start with 1 minus 2x. Do you understand? Okay. And that satisfies this second condition. Okay. Now, how do we now sketch our graph? How do we draw the graph? You can draw the graph now simply by illustrating this. This is it. Don't forget, our x is greater than or equals to half, less than half. Okay. For the fact that we have what? Half, our x will be here. Don't forget our x will be there, because it's x greater than or equals to half is included in that sketch. So now don't forget also that 2x minus 1, absolute value of 2x minus 1 goes up. So we have positive values of it, we have negative values of it. Yes. So here we have x is half. That point you can see. So these are our x values. X goes like that. These are x negative, y positive. As you can see, y negative. This is your 0. It will not converge here. It is converging at half. The two values. This one has greater than or equals to half. This one has less than half. So it converges there. So you can now say the graph. This one is what? Y is 2x minus 1. This is y is minus so y is equals to, what do you have there? Okay, 1 minus 2x. And so now, what is the range? Now, to get the range is very, very simple. Okay, the range R of the function is set of y values, which is got what? Y such that y such that or you can just y greater than or equals to 0. Y greater than or equals to 0 for y. Y greater than or equals to 0 for y. But what is your what? What is your x? What's the domain of the function? Obviously, the domain of the functions here is set of what? Real numbers, because it's x increases. So x increases. X increases. So that we have sketched that absolute value function. So just go through it once again, study how it is expressed, you will definitely get it. So I will continue with some more examples in the next video. Stay blessed.